Frequency spectrum and bandwidth. The modulator carrier has new signals at different frequencies and it is called as side frequencies or sidebands, and they occur above and below the carrier frequency. Okay, we have our upper sideband as well as lower sideband. USB is upper sideband and LSB is lower sideband, and FC is the carrier frequency and FM is the modulating signal frequency. So FUSB is equal to FC plus FM. FLSB is equal to FC minus FM. Okay, here EAM is equal to EC plus EM sin omega MT of sin omega CT. So this is our AM wave equation. Okay, and we all know that M is equal to EM by EC. Okay, so we are going to substitute here. What we are going to do now, we are going to substitute EM is equal to M into EC here in the statement. Okay, so what happens, EAM is equal to EC plus M into EC sin omega MT into sin omega CT. Okay, so if you take EC as common out, EAM is equal to EC of 1 plus M sin omega MT into sin omega CT. Okay, so we can rearrange our equation and we can write it as EAM is equal to EC sin omega CT plus M into EC sin omega MT into sin omega CT. Okay, and we can here what happens, this particular equation, it's in the form of sin A sin B. Okay, so we all know that sin A sin B is equal to 1 by 2 cos of A minus B minus 1 by 2 cos of A plus B. Okay, so if we apply this to the these two terms, our equation will be changed as EC sin omega CT plus M EC cos omega C minus omega M by 2 minus M EC by 2 cos of omega C plus omega M into T. So what we are doing, we are converting this part of the equation sin which is in the form of sin A sin B to the format that is given below. Okay, so what happens next, this contains the full carrier and the both sidebands. Okay, so hence it is called as double sideband full carrier system. Okay, so if we rearrange our equation, EAM is equal to EC, and in terms of if you substitute, omega is equal to 2 pi and omega C is equal to 2 pi FC and omega M is equal to 2 pi FM, we will get our equation as EC sin 2 pi omega 2 pi FCT plus MEC by 2 cos 2 pi of FC minus FM into T minus MEC by 2 cos 2 pi of FC plus FM into T. Okay, so here what happens, MEC by 2 cos 2 pi of FC minus FM. So what is FC minus FM? It is our lower sideband frequency, and FC plus FM is our upper sideband frequency. So this is our lower sideband frequency and upper sideband frequency, and it also has a full carrier in the equation. So our equation consists all the waveforms that are mentioned in this spectrum. Okay, so this contains full carrier and both sidebands, and it is called as double sideband full carrier system. Okay, so we know that the bandwidth of the signal can be obtained by taking the difference between the highest and lowest frequency. Okay, so our bandwidth is nothing but FUSB minus FLSB. Okay, upper sideband minus lower sideband. So FC plus FM minus of FC minus FM. So if you solve this equation, our bandwidth will be uh, 2 FM. Okay. Next is AM power dissipation. Our AM signal has three components: an unmodulated carrier, a lower sideband, and a upper sideband. Okay. So our AM signal has a three components: unmodulated carrier, lower sideband, and upper sideband. Okay. Means the total power of the AM wave is nothing but the sum of the carriers. Okay, so P total is equal to PC plus P upper sideband plus P lower sideband. So P is equal to E square by R. Okay, so what happened? E square carrier by R plus E square LSB by R plus E square USB by R. Okay, here all the three voltages are in RMS voltage, and R is the characteristic impedance of the antenna in which the power is dissipated. The carrier power is given as PC is equal to E E carrier by R E square carrier by R, which is equal to EC square by 2R. Okay, and PLSB is equal to PUSB, which is equal to E square SB by R. Okay, and ESB is nothing but the RMS voltage of the sideband. Okay, so ESB is equal to we already know what is ESB. So these two are nothing but we are taking it as sideband power. Okay, so MEC divided by 2. Okay, so this is nothing but a peak amplitude of both the sidebands. Okay, MEC by 2 divided by root 2. Okay.